Hello all. So in the previous lecture we have seen different normal forms. First normal form, second normal form and third normal form. And we have seen how the steps for normalization into third normal form. That is how to disallow this partial and transitive dependency. When we have this partial and transitive dependencies, the problem is all those anomalies will happen. Whatever we have learned in the previous informal guidelines, we have seen some anomalies. So all those anomalies happen if it is not properly normalized. So we have already seen how to disallow this partial and transitive dependency on the primary key. So we have considered only the primary key in the previous lecture. But the normalization procedure for practical situations, we need to consider not only the primary keys, we have to consider all the candidate keys. So in the previous definition and all, we have considered only the primary key of the relation. So in this lecture, we will see general normal form definition, that is second normal form, third normal form, and also we will introduce one more normal form, that is Boyce-Codd normal form, BCNF. So second normal form and third normal form we have already seen based on primary key. Now we will see based on candidate keys. So there are there are other keys in that relation. So all those keys are known as candidate keys. So this is the outline of this lecture. We will see general normal form, definition of the second normal form, general definition of third normal form, BCNF. So general normal form definitions for multiple keys. So if you have multiple keys, we have to change the previous definitions. So previous definitions consider the primary key only. So we have to consider multiple keys. So general definitions will consider multiple candidate keys. So in the previous lecture, we have already seen about primary key. Now we have to change a bit. So we have to change that primary attribute definition. In the previous lecture, we have defined that prime attribute is any attribute that is part of a primary key. But we have changing that thing. Any attribute involved in a candidate key or any attribute inside a candidate key is considered to be prime attribute. For this general normal definition, we will be changing that definition. So prime attribute is any attribute that is part of a candidate key. All other attributes are called non-prime attributes. Okay, all other attributes are called non-prime attributes. Now we will define general definition for this second normal form. So a relation schema R is in second normal form if every non-prime attribute A in R is fully functional dependent on every key of the R. So that is the only difference. In the earlier case, we have considered only primary key. Here we are making it every key of R. So there are different candidate keys also. So we have to consider all those things. So every key means all candidate keys. So on all candidate keys, the non-prime every non-prime attribute should be fully functionally dependent on all candidate keys. Okay. So we will see an example. So this is a table, lots table. So we have property ID as a primary key. There is one more candidate key in it. So there is one more candidate key. This combination, county name, comma, lot number. This combination is another key of this relation. So this is another key of this relation. So the prime attributes are property ID, county name, and lot number. Non-prime attributes are area, price, and tax rate. Okay, so area, price, and tax rate are the non-prime attributes. So as per definition, what we have to see, every non-prime attribute. So every non-prime attribute should be fully functional dependent on every key of R. So it should be fully functional dependent on every key of R. So non-prime attribute area should be fully functional dependent on property ID. It is true. Then area should be fully functional dependent on county name, lot number, that combination. So it is there. That combination is there. Area, county number and lot number, that combination area is fully functional dependent on it. Area, county name and lot number. Similarly, price should be functional dependent on property ID. That is the first candidate key. Then price should be fully functional dependent on county name and lot number. That is the second candidate key. So it is satisfying that condition. Then the third condition, then the third non-prime attribute, that is tax rate. Tax rate should be fully functional dependent on county name and lot number. Then also tax rate should be fully functional dependent on property ID also. Okay. Now, if we check, we can see that tax rate depends on county name alone. So, tax rate is not fully functional dependent on the candidate key. So, there is a partial dependency of tax rate. So, tax rate on county name. So, county name is part of candidate key. So, there is a partial dependency tax rate. So, as per this thing, it is not allowed. So this tax county name to function tax rate, this functional dependency is not allowed because this is partially dependent. So we should have fully functional dependent on every key of the R. So there is a partial dependency here. So how to remove this partial dependency? The same thing. We have to decompose it into two tables. So we have to remove this county name and tax rate to another table. So it becomes lots 2, county name and tax rate to another table, and the primary key there is county name. Now tax rate is fully functional dependent on county name. Now we have removed this tax rate from this, the rest of the attributes will be there. Now if you check, it is fully functional dependent. So the non-prime attributes area and price are the non-prime attributes. It is fully functional dependent on both the candidate keys. One is property ID, then the other candidate key is county name and lot number. So it is, these two tables are in second normal form. So this table is also in second normal form because every non-prime attribute is fully functional dependent on the every candidate key. So here the candidate key is county name alone. Okay. So these two relations are in second normal form. So we have decomposed this table into two or normalized into two. Now these two tables are in second normal form. Now we will see general definition of third normal form. Before that, we have to define what is a superkey of relation R. It is a set of attributes S of R that contains a key of R. We have already seen the superkey definition. A relation schema R is in third normal form if whenever a functional dependency X to A hold. So a relation schema R is in third normal form if there is a functional dependency X to A holds in R, then either X is a super key of R. So either X should be a super key of R or A should be a prime attribute of R. So this is a condition for third normal form. So it is in third normal form. We have to take every functional dependency. So X to A. So X should be either a super key. If this is not the case, if X is not the super key, then at least A is a prime attribute of R. Any of these conditions should be there. Then only we can say that table is in second normal, third normal form. So we will see an example. Here this is a table. We have lots 1 and lots 2. So we have already seen this table. So this is a table here. So this lots 1 and lots 2, we are redrawing it here. So lots 1 and lots 2 here. So this is in second normal form. We have already seen that these two tables are in second normal form. Now if we check this table, so what is the condition for second normal form? X to A is there, then X is a super key or A is a prime attribute. Now the functional dependency here is property ID to county name, lot number, area and price. So here in all those cases X is a super key, property ID is a super key, or it can be considered as a primary key or candidate key. Then the other functional dependency is county name and lot number to area, price and property ID. Here county name and lot number are primary keys, so candidate keys. So that functional dependency is also okay. But we have one more functional dependency is in this table, that is area to price. That is price is dependent on A. So this X is area and A is price. So as per the definition, X should be a super key. Here X area is not a super key. If it is not super key, then at least A should be a prime attribute of R. And here price is not a prime attribute because here the prime attributes are property ID, county name and lot number. So price is not a prime attribute. So this table violates third normal form condition. So we have to make it as third normal form. So for that, we have to remove this area and price into another table. This functional dependency should be removed and stored in another table. So this will become like this, area to price. So this is, and we have removed this price. Now if we check this table, either x to a, x is a super key, or a is a prime attribute, or in this case x to a, x is a primary key, or x is a super key, x is a super key, or the other thing price. So these two relations are in third normal form. So now we have split the lots 1 into lots 1a and lots 1b, and these three relations are now in third normal form, lots 1a, 1b and lots 2. So this is what we have done. We have started with lots which was in first normal form. We have split into lots 1 and lots 2 to make it second normal form. Now lots 1 again we have split it into lots 1a and lots 1b to make it third normal form. So now these three relations are in third normal form. So you have to check the definition. You have to study this definition. So if there is a functional dependency x to a, then x is a super key or a is a prime attribute. Okay. So that is third normal form. So we have already seen this example. So we'll interpret the general definition. So consider the two conditions in the definition of third normal form. A relation schema R is in third normal form if whenever a functional dependency x to a holds, then either x is a super key of R or a is a prime attribute of R. So we have already seen this definition. Now consider A so here condition A catches two types of violations. So if we make x as a super key of R, then it catches two violations. One where a prime attribute functionally determines a non-prime attribute, automatically what happens? It catches second normal form violations due to non-full functional dependencies. Because if the relation satisfies this condition, x is a super key. So whenever there is a functional dependency, x is a super key. Means all other attributes will be fully functional dependent on x. So it automatically satisfies second normal form. So it catches all the second normal form violations. Okay. And second, where a non-prime attribute functionally determines a non-prime attribute also. So this will also be caught here because it catches third normal form violations due to transitive dependency. So transitive dependency occurs if there is a functional dependency x to a and if there is a dependency from a to some other b, then there can be a possibility of x to b. But if a is a prime attribute, then that transitive dependency is not a problem. We have already seen. So x to a and a to b, and if a is a prime attribute, then it is not at all a problem. So that is how we remove this condition. If a is made a prime attribute, then automatically third normal form will also be satisfied. So with this condition, where a non-prime attribute functionally determines a non-prime attribute, this condition is also removed here. So it catches third normal form violations due to transitive dependency. So this B condition catches this third normal form violation also. So this condition is generally can be considered. So if we directly normalize to third normal form, we automatically make it second normal form also. We need not first normalize into second normal form, then to third. It is not necessary. If we directly check whether these conditions are satisfied, then it will automatically be in second normal form and third normal form due to these two things. Okay. Then alternative definition for this third normal form, a relation schema R is in third normal form if every non-prime attribute in R meets both of these conditions. So it is fully functionally dependent on every key of R, and also it is non-transitively dependent on every key of R. So this way also we can define it. So we have to learn this way and the other way also. That is, X is either a super key of the relation or A is a prime attribute. Next, we have one more stricter normal form which is known as Boyce-Codd normal form. The other three normal forms were designed by Codd. Later, Boyce also came up with another normal form, and he joined with Codd, and they together designed this Boyce-Codd normal form, Boyce-Codd, BCNF. We call it as Boyce-Codd normal form, BCNF. Okay. So we will see this BCNF. So a relation schema R is in BCNF if whenever a functional dependency x to a holds in R, then X is a super key of R. So it is much more stricter than the third normal form. So in third normal form, we have this condition. It should be either X is a super key or A is a prime attribute. So that second condition is removed in this BCNF. That second condition is removed. If whenever there is a functional dependency x to A is there, then X should be always a primary key of that relation or super key of that relation. So each normal form is stricter or strictly stronger than the previous one. So every second normal form relation will be automatically in first normal form. Every third normal relation is in second normal form. Every BCNF relation will be in third normal form also. So there exist relations that are in third normal form but not in BCNF. Hence, BCNF is considered a stronger form of third normal form. So, usually when you design these tables, you have to normalize at least up to third normal form. And if possible, you can normalize up to BCNF also. So, it is mandatory that you should normalize at least up to third normal form. So the goal is to have each relation in BCNF or in third normal form. Okay. So this is the condition. So this is same as that third normal form condition. The only thing is that the second condition in third normal form has been removed. That x to A is either X is a super key or A is a prime attribute. That A is a prime attribute has been removed, and this is the only condition. X should be always a super key of R. Okay. So we will see that example. So this is in third normal form. We have already seen this relation, lots 1a. So we have already seen this thing. So we have already seen that example. So lots 1a and lots 1b. Now lots 1a is in third normal form. We have already seen. So we have one more functional dependency which we have not shown there. So area to county name. There is a functional dependency FD5, area to county name. So this is in third normal form because area to county name, as per third normal form, area x should be either a super key. So x is not a super key, area is not a super key, or a can be a prime attribute. Here county name is a prime attribute. So FT5, this is not a problem in the case of third normal form. So this is in third normal form, but this is not in third normal form because if there is a function dependency like this x to A, then Ax should be super key, but area is not a super key. So this functional dependency should be removed. We can normalize into BCNF by making this functional dependency separately. That is, area and county name will be made separate, and property ID, area, lot number will form another relation. So lots 1a becomes lot 1ax and lot 1y. Then the other things will also be there. That's lots 1b will be there, lots 2 will be there. Then all together will form the BCNF normalized relations. Okay. So this is a thing. So here, if we have a relation A, B, C, and this is fully functional dependency, this is in third normal form. And if there is a dependency C to B, this is in third normal form because B is a prime attribute. B is a part of that primary key or part of a candidate key. So C to B, in the case of third normal form, it is not a problem. But in the case of BCNF, this is a problem because C should be a super key. In this case, C is not a super key. So in this case, area is not a super key. So this functional dependency is a problem. It violates BCNF. So in order to make it BCNF, we decompose it into two relations. So this is another example for this BCNF. We have teach relation is there. Student, course, and instructor is there. Student, course, and instructor is there. These are the different attributes, or these are the different tuples in it. And if you see this functional dependency is there. Student, comma, course to instructor is there, and also functional dependency is there, instructor to course. So here the key of this relation is student instructor. This combination is the key. So it is, there is fully functional dependency is there. Instructor is fully dependent on student and instruction. So it is not a problem. But we have a problem here. There is a functional dependency from instructor to course. It is in third normal form because course is a prime attribute, so it is not a problem. But it is not in BCNF because instructor is not a super key. So this is not in BCNF. So in order to make it into BCNF, we should either do like this: student and instructor in one table and student and course in another table, or we can make it like this: course and instructor in one relation and course and student in another relation. And also we can make it like this: instructor and course in one relation and instructor and student in another relation. So all these three will be in BCNF. But there is a problem with this thing. So all this decomposition will lose one functional dependency. So we have a functional dependency student comma course to instructor. So this functional dependency, that is instructor is fully functional dependent on student and course, that is not seen in any of this decomposition. So if we check, that decomposition will not be there. That functional dependency will not be here. In these two relations also, this functional dependency is not there. In this also, this functional dependency will not be there. So we have lost one functional dependency when we try to decompose into BCNF. Okay, so it is not necessary that you should always decompose into the BCNF. In certain cases, this will be the problem. We have lost that functional dependency. So dependency should be preserved, and lossless join property, that too should property should be satisfied. We will be learning about this later. So here, if we split like this, in all these three are in BCNF. So if we see this first case, these two relations are in BCNF. These two relations are also in BCNF. These two relations are also in BCNF. So we can decompose in any of these manner. But the problem is, in all these decompositions, we have lost this functional dependency. Okay. So I have given three exercises in this. So this is exercise 7. So this is a database state. Now you have to check which of the following dependencies may hold in the above relation. So if the dependency cannot hold, explain why by specifying the tuples that cause the violation. So you have already learned functional dependency. Now you have to check with this. You have to check whether A to B is whether B is functional dependent. If it is not functional dependent, which all rows violate that thing. So you have to check B to C, then C to B, B to A, and C to A. So this is first exercise. You have to check which all functional dependencies hold, and if it is not holding, you have to explain why it is not holding that functional dependency. Then the second exercise here, you have to consider the relation R, which has attributes that hold schedules of courses and sections at a university. So this is a relation R with course number, section number, offering department, credit hours, course level, instructor assessment, semester, year, days underscore hours, then room number, number of students. Now suppose that the following functional dependencies hold. So these are the different functional dependencies which are there. Course number 2, offering department, credit hours, and course level. Then course number, section number, semester, year 2, days, hours, room numbers, number of students, instructor, and then there is another functional dependency: room number, comma, day, hours, comma, semester, comma, year 2, instructor, assessment, course number, section number. Try to determine which set of attributes form keys of R. So we have to find which is the key of this R, which are the keys of this R. Then you have to normalize this. So you have to check whether it is in first normal form, second normal form, third normal form, like that. And you have to normalize at least up to third normal form. One more exercise is there. So you have to do this exercise 3. Then you have to do this exercise also. So consider the following relation: car sale. These are the attributes: car number, date sold, salesperson, commission percentage, then discount amount. So assume that a car may be sold by multiple salesperson people, and hence car comma salesperson is the primary key. So here primary key has been mentioned. Then the additional dependencies are date sold to discount amount and salesperson number to commission percentage. So based on the given primary key is relation, you have to check whether it is in first normal form, second normal form, or third normal form. Why or why not? You have to find. If not, how would you successfully normalize it completely? Try to normalize it up to third normal form. Okay, so it is primary key is already given. You have to check all these conditions and you have to normalize it. So this is a reference. Thank you.